Okay, it's time for our general chemistry memorization quiz. Name these: SO4 2 minus, SO3 2 minus, and OH minus. Pause the video and make sure you get all of these down. Well, they're all anions. This happens to be a dianion. These happens to be monoanions. And those memorized names are sulfate, sulfite, and hydroxide. How about a nitrate, a cyanide, and a carbonate? A nitrate is NO3 minus, a cyanide is CN minus, and a carbonate is CO3 2 minus. What are the diatomic elements? Well, one way I didn't teach would be to say it's Janine. If it ends with GEN or INE, you got 'em. I prefer H. Broncliffe, meaning hydrogen, bromine, oxygen, nitrogen, chlorine, iodine, and fluorine. You know, it's interesting that I almost said fluoride because if they're anions, they're not diatomic, right? Sodium fluoride is NaF. Sodium chloride is NaCl. They are only true if they are atomic rather than ionic. They make this huge difference, you know. A hydrogen atom is H, but H plus, if you're asked on a test, they often want you to say that's not an atom at all. That is an anion, specifically a cation. What are the 6 strong acids? Hydrochloric, hydrobromic, hydriodic, perchloric, nitric, and sulfuric. Did I miss one? I don't think so. Hydrochloric, hydrobromic, hydriodic. Did I say that one? Nitric, sulfuric, and perchloric. Hey, list 4 ions that if you see them, that ionic compound is water soluble. End of story. I hope you remembered that. Spam mnemonic. So sodium, potassium, ammonium, and nitrate. How many significant figures are in each of these 3 numbers? 1.0. 2, because we keep the 0 if there's a decimal place. 0.010. The answer is 2, because we always dump leading zeros. And 10. And notice that somebody did a nice thing. They didn't just write the question mark and leave it sort of nebulous. They had the period. They had the decimal place, I should say, not a period, then the question mark. So I do see a decimal place, so I'm going to say 2 for each. Here's a combination one. Will your professor teach it? I hope so. Watch that nice 8-minute video, and you should see that first we're going to write this one down exactly, meaning the raw number, but we're only going to underline the numbers that are 0. Now this answer is interesting because when you get it, your calculator is just going to spit out 8. But it is accurate to the hundredth, so make sure you write 8.00 as your intermediate number there, and that'll be multiplied by 5.000. So we have to keep 3 significant figures, and the answer is 40.0. What are these? Oh, I didn't want to give the answer there. What are these, and what are they good for? Okay, a beaker, a graduated cylinder, and a flask. I did mention what these are generally good for, so let's try to summarize. Beakers, main thing they're good for is just pouring, right? They're not very good for stirring. Things tend to fall out. They're not very good for storing. You can't really cap them. But for pouring, boy, they're wonderful. An Erlenmeyer graduated cylinder is lousy for stirring. It's lousy for, you really don't want to store stuff in that. It just seems like a waste. But it's great for measuring because you can even interpolate between the digits to estimate one, right? So you can get some pretty good precision with them. There is a device I just want to mention in passing that can give you even higher precision, and that is called a volumetric flask. We should have more to say about that later. Okay, and this is an Erlenmeyer flask. It's lousy for measuring. They even say approximate on these. These ones are lousy for measuring. They don't even worry about these numbers. They just print them on. But this one happens to be great for swirling, so you can mix things so well in this without things splashing out. It's also pretty good for storing because you can cap that thing up. So there it is. Okay, that is the general chemistry memorization quiz.